Hi everyone, welcome to this lecture. So in this lecture, we will solve our project 5 on logistic regression. And for this project, we are going to select a challenging dataset. That is, this dataset will be more challenging than the previous projects. So I am here in my logistic regression folder, and I have here my project 5. If I click on this file, it will be open in Google Colab environment. So click on this file, and here I am in my project 5. So for my project 5, I need to import all these necessary Python libraries. That is, I need logistic regression, I need train test split, I need NumPy, Matplotlib, and I need pandas. So let's run this cell in order to import all the necessary libraries. So for this project, I am going to use the dataset known as Titanic _train.csv. So this data is present inside my logistic regression folder. So this is my logistic regression folder, and here is the dataset. We know that in order to read the dataset from the particular folder, we need to mount the drive and we need to set the path. So in order to save the time, we have already mounted the drive here and we have already set the path. Now you know how to mount the drive and how to set the path. We have done this now many times in this section and in the previous section of the course. Now it's time to import the data. Let's run this cell. So data have been imported and we can see the shape of the data. It has 891 samples and 12 columns. Let's see the head of the data, that is the first 5 sample of the data. So we can see that this data set has quite a few number of features. We have passenger ID, survived. Now survived, this column we will not use as a feature and we will use is as a label. And it has two unique values, that is 0 and 1. If the passenger survived, we will assign a label 1, and if it is died, the label will be 0 for that passenger. This is passenger class, name of the passenger, sex, age, and there are two more features. Let's see what does these features mean. We have a ticket number, we have fare, we have a cabin, and we have embarked. So the last column is embarked. So embarked implies where the traveler mounted from. So there are three possible values for embark: Southampton, Cherbourg, and Queenstown. So these were the three places from where the traveler mounted. So we will find that this column will have three values. Similarly, a sex is also a categorical column. So this embarked is the categorical column. Sex is also a categorical column. It has two values, male and female. Now these two columns, SIB, SB, and PARS. So basically, if we see SIB, SB is the number of siblings or spouse of a person on board, and PARS is the feature contained the number of parents or children each passenger was touring with. So basically, these two features represent the number of family members traveling with the passenger. Now, this is a challenging dataset because it has a feature in the form of integers like the passenger class. We have features in the form of categories like sex and embarked, and we have features in the form of float like fare. So in this way, we have every kind of features. Now, first step should be to check the number of passengers died and number of passengers which are survived. So we have to use the information of this column, which is the survived. So the name of our data is train. So what we are going to do is to extract the value count information from this column survived. Let's run this cell and we can see that there are 549 passengers who died in the Titanic accident and there are 342 passengers who survived. So we can see that about 60% of the passenger died. Now it's time to drop the irrelevant feature. So if we go back to the passenger ID, the name of the passenger, similarly the ticket and the cabin. So these are the irrelevant features because they are not influencing our survived, which is our label. So they are the irrelevant features. They have no effect or influence on our target variables. So in that case, we can easily remove them by running a command train.drop, and here we are passing the name of the columns. Since these are column, therefore axis is equals to 1 and in place is equals to true, means we are removing them permanently. Let's run this cell to remove them permanently. Now we are going to check the null values of our data set. Let's run this cell. So we have train dot is null any. So we can see that we have null values in the age column and we have null values in the embarked column. Now age column is a column where we have the values in terms of float. So how to deal with the null values which are present in the age? So basically what we will do, we will calculate the mean value of the column age and we will replace the null value in this column with the mean value. So how to do this? So we will use train.fillna. Train.fillna means fill the null values. So how to fill the value? We will calculate the mean of the age column and then we will replace the null value of the age column with that mean value, and then we will write in place is equals to true. In place is equals to true means that we are going to change it permanently. So let's run this cell and now check the null values again. So if we see that there are no null values in the age column now it's time to deal with the null value in the embarked column. Now for embarked column, what is our strategy? That we are going to drop those samples which have the null values. So we are going to use train dot drop null values NA, that is drop null values in place is equals to true, that we want to drop these values permanently. So let's run this cell and now check the null values again. So we can see that there are no more null values in any of the column. And now we can check our data set again. So we can see that this is the data set without the null values. So in the first step of the data cleaning, what we have done is that we have removed the null values and we have dropped the irrelevant feature. After removing the null values and after dropping the irrelevant features, now we are left with those number of features, that is the passenger class, sex, age, SIP SB, this is part, then fare and embarked. So this first column survived will be our label. So I stop this lecture here. In the next lecture, I will continue this project. See you there.